Hey class, it's your favorite teacher, Mr. Falstrom, and we are going to start a new unit in math, and it's all about decimals. And later on in the unit, we're going to be adding and subtracting decimals. But before we jump into that, first we're going to do an introduction on just what are decimals. So let's get started. Our learning goal for this lesson is pretty simple. We are just going to use our understanding of place value, and we're going to use that to model, read, and write decimals to thousandths. And if you don't know what thousandths mean, don't worry. By the end of the video, you will. Before we can actually jump into discussing what decimals are, first we actually need to spend a little bit of time talking about place value. And here's a place value chart. It goes from the ones place to the millions place, and you should be pretty familiar with a place value chart that looks like this. We spent actually a lot of time at the beginning of the year talking about place value, and I know that in other earlier grades you also spent time learning about place value. And I just want to point out that all of these place values represent whole numbers. So ones, tens, hundreds, thousands, so on. Whole numbers are our counting numbers. So for example, 0, 1, 2, 3, 4, 5, 6, 7, and so on. So these are whole numbers. And some examples of whole numbers: 17 is a whole number, 245, 3, 18,236, 9,879,234,146. Those are all whole numbers. And if we zoom in on the chart a little bigger, I just want to point out that we spent a lot of time talking about powers of 10 and place value. So for example, the tens place is 10 times bigger than the ones place. And that keeps going as we move towards the left. Every time we go to the left, we're adding a place. Each place to the left is 10 times bigger than the place to its right. So the hundreds place is 10 times bigger than the tens place. The thousands place is 10 times bigger than the hundreds place, and so on. And we can even compare place values that aren't next to each other using powers of 10. For example, the hundreds place is 100 times bigger than the ones place because it is 2 powers of 10 bigger. 10 times 10, 100. So it's 100 times bigger, and so on. And it also works going the other way. We don't just use place value to look at how much bigger numbers are. We can also use place value to look at how much smaller numbers are, so we can go the other way. If we go to the right, each place to the right is 10 times smaller than the place to the left. So the hundreds, thousands place is 10 times smaller than the millions place. And it just keeps going. The 10,000s place is 10 times smaller than the 100,000s place. The ones place is 10 times smaller than the tens place. And we've talked about all this before, but really what we need to talk to you now is, okay, we've talked about all these whole numbers, but what about numbers that are smaller than 1? We haven't really talked about those yet. So what actually, is there anything after, before the ones place? What do we call the places that are smaller than 1? And you might not realize it, but there are actually a ton of numbers that exist between 0 and 1. They're just really small numbers. And a great way to think about it is to picture a number line. So here we have 0 and we have 1, and look in between. There's so many different numbers that exist in between there that you could put a point on and name. And just as an example, I'll just give you an easy one. We'll just use a fraction, because fractions are examples of numbers smaller than 1. A half is smaller than 1. And I want to talk about fractions really quick, just because fractions are numbers that are parts or pieces of a whole, which is a really important connection because decimals and fractions are basically the same thing. decimals are pieces of numbers. They're less than one. They're small numbers. And so, in other words, we have whole number places that represent the counting numbers, starting from 1 and counting all the way up as high as we want. And then we have decimal number places for the numbers that are less than 1. So again, just to say it one more time, whole number places are for numbers that are greater than or equal to 1. So you start at 1 and just go as high as you want. But decimal places are numbers that are less than 1, and they're small. They're pieces of numbers. They're little parts of a number. They're smaller than a whole number. And so what we need to do is we need to update our place value chart, and we're going to include decimal places and whole number places. So here's our new chart, and here's some whole number places. Okay, we got ones, tens, hundreds, thousands. And then over on the right side, we now have some decimal number places. So all of these are smaller than 1. We have tenths, hundredths, and thousandths. And there are a lot more decimal places than that. But for 5th grade, we really never go past thousandths. So these are the 3 main ones that we're really going to focus on this year. And then separating the ones, or separating the whole numbers and the decimals, we have the decimal point, right? So the decimal point is it's always in between the ones place and the tenths place. So to help us understand decimal places a little bit better, we're going to do some modeling with base 10 blocks. And obviously, I'm not going to actually use real blocks. We're going to look at pictures and we're going to have to visualize a little bit. And no, not that kind of modeling, like this kind of modeling. So here's the basic base 10 blocks that we use, right? We have our ones cube, we have our long, which is 10 cubes, and then we have our flat, which is worth 10 of the longs, and it has their values. So ones cube is worth 1, a long is worth 10, and a flat is worth 100. But if decimal numbers are smaller than 1, that means we're going to have to use our imaginations a little bit. So here's what we're going to do. This is our ones cube. What we're going to do is we're going to pretend that we have a magnifying glass, and we're going to zoom in on it and make it look really big. So pretend that it's getting bigger. Okay, we've zoomed in on the cube. And what we're going to do is we're going to cut it into 10 little pieces. And each piece, since we cut it into 10 equal parts, each piece is called a tenth. And 10 of these tenths, if we add up all of these tenths, all of them, they're equal to that 1 cube. So 10 tenths is equal to 1. And we've cut up our ones cube into 10 equal parts. Each piece is smaller than 1. And here I have shaded 1/10 red. And 1/10 is a decimal number because 1/10 it is smaller than 1. How do I write 1/10 as a decimal number? Like this. 1/10 is written like that. So you can see I have 0 in the ones place. I have a decimal point. In the tenths place, I have a 1 to show that 1/10 is shaded. You can also write 1/10 as a fraction because decimals and fractions are very, very, they're just different number forms, really. So 1/10, you can write it like that, 1/10, because out of the 10 parts, 1 part is shaded. If you think of this as a fraction, it makes a lot of sense. Our numerator is 1, and we have 1 part that's shaded, and then there are how many total parts make up the whole thing? There are 10 parts that make up the whole thing, but only one of them is shaded. Here I have shaded 2/10 red. How do I express 2/10 as a decimal number? Well, just like that. 0 in the ones place, decimal point, and a 2 in the tenths place. That is how you write 2/10. As a fraction, 2/10. Here, I've shaded 7/10 red. So how would you write 7/10 as a decimal number? Like that. 0 in the ones place, because this is less than 1. I've only, the whole thing, if the whole thing was shaded, that would be equal to 1. But here we only have 7 out of the 10. So 7/10, and that's also how you would write it as a fraction. Here, I've shaded all 10/10 red. How do I write 10/10 as a decimal number? Well, here's a hint. As a fraction, I'd write it as 10/10. And if you know what 10/10 is equal to, then you'll know what to do. But if you're not sure, let's go a little deeper. So to answer the question of how to write 10/10 as a decimal, let's look at a familiar situation with whole numbers instead. So remember, our number system, it uses base 10, which means that whenever we have 10 of something, we rename it and we move it up to the next biggest place. So right here, I have a chart. If I have 10 ones, I don't keep them all as 10 ones. What I would do is I would exchange them, right? 10 ones is actually equal to 10. So 10 ones is equal to 110, right? If I had 10 tens, I would turn that into 100. And if I had 10 hundreds, I would turn that into 1,000. So we regroup and rename with decimal numbers the exact same way we do with whole numbers. So if we have 10 tenths, what we're going to do is we're just going to regroup that. And 10 tenths is going to be the same thing as 1. So 10 tenths is equal to 1. And again, 10 ones is equal to 10. 10 tens is equal to 100. So whenever you have 10 of something, you add a place. You exchange and move and trade up. So let's talk about what if we took tenths? What if we took every tenth and cut those into 10 equal parts? Now the pieces have gotten even smaller, right? Remember, this whole thing is a ones cube. It's equal to 1. And now we've cut it into 10 tiny pieces. And now we've taken those pieces and cut those into 10 tiny pieces. Now we have really tiny pieces. And if you look at how many total pieces there are, each piece here is called 100th because there are now 100 tiny pieces. So that is the next decimal place after tenths. After tenths, we get even smaller and we go to hundredths. And right here, I've shaded 100th red. How do I write 100th as a decimal? Like that, with a 1 in the hundredths place. So 0 in the ones place, a 0 in the tenths place, but a 1 in the hundredths place. As a fraction, I write it as 1/100 because out of the 100 total pieces here that make up the ones cube, only one of those 100 pieces is shaded. Here, I've shaded 10 hundredths red. How do I write 10 hundredths as a decimal number? And I write it like that. And you might notice that the 1 is in the tenths place. Well, that's because 10 hundredths is the same thing as 1/10. As a fraction, we could also write it as 10/100, but I just want to kind of show you that. Notice how I took the lines away? That whole thing, it's equal to a tenth. So that's how we write it. And when you say it, notice that when I wrote 10 hundredths there at the top, You always, whatever the very last place in the number is, that's how you say it. Since there's a 0 in the hundredths place, I got to say 10 hundredths. Here I shaded 74 hundredths red. How do I write 74 hundredths as a decimal number? Like that. 74 hundredths. And again, you'll see that there's a 7 in the tens place because 10 of those columns are completely, or not 10, 7 of those columns are completely shaded, which is the same thing as 7/10 being shaded. And then I have those 4 little hundred squares left over. So as a fraction, you write it as 74 over 100. And if we were able to zoom in again on the hundredths cubes and cut all of those into 10 equal and even tinier pieces, we would create thousandths. And you can keep on going. If you look at this graphic right here, we've got all the black numbers are the whole numbers. Then we have a decimal point, and then in the red, we have all the decimal numbers. And you can see we have tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, and it keeps going. It keeps going on and on and on. So it gets so small that I can't even think of a way that I could even try and show you pieces that small. So we're going to stop after hundredths. But just realize that every time you're going to the right with a decimal, you're getting smaller and smaller and smaller and smaller, and you're cutting the pieces every time you're taking the pieces you have and cutting them into 10 smaller parts, and then you take those and cut them in even 10 smaller parts, and you keep going and going and going. And here's a real life connection alert. A great example of decimals in our everyday lives is money, because our money system is also based on the same base 10 place value system that we use for numbers. So $1, that's how we write it. When you look at prices in the store, $1, you see a 1 in the ones place, and then you see a decimal point, and you see a 0 in the tens place and a 0 in the hundredths place. A dime is 10 cents, and we write that with a 1 in the tenths place. And a dime is 1/10 of a dollar. It takes 10 dimes to equal that $1. And then pennies represent hundredths. And 1 penny is 1/100th of a dollar, because you need 100 pennies to equal a dollar. So right there, even if you don't realize it, if you've ever counted change or paid for things with money or paid attention to prices when you go shopping, you've been already kind of thinking about decimals already. And here's a quick note about the decimal point. When you are saying a number out loud, like I am saying numbers right now, the decimal point, when you see the way you say the decimal point, you say the word and. So for example, this number, you don't say 1.4. A lot of people say that, and I say it sometimes too. But the correct, proper way that we're supposed to say it is we're supposed to say 1 and 4/10. So again, when you pronounce the decimal point, you say the word and, you don't say point. 1 and 4/10. And just point out that 1, that's the whole number part, and then that's the decimal part. How do you say this number? You say 0 and 15 hundredths. Or you could just say 15 hundredths. But I like to say 0 and 15 hundredths, because then, because sometimes if you just say 15 hundredths and you don't say it really clearly, sometimes people might think you might have said 1500, and then it's confusing. But if you say 0 and 15 hundredths, it kind of helps you recognize that that person's trying to name a decimal. How about this number? How do you say this number? 12 and 3/10. Simple. One more. How do you say this one? 1 and 5 thousandths, because the 5 is in the thousandths place. So it's time to test your knowledge on some questions. What decimal am I showing you with the red shaded part? And the decimal I showed you is 4/10, because if you look at the whole cube that I'm showing you, it's divided into 10 equal parts. And out of those 10 equal parts, 4 of the 10 4/10 are shaded. How about right here? What decimal am I showing you here with this model? And on this one, I am modeling 8/10. 8 of the tenths are shaded red, and 2 are not shaded. What decimal am I modeling for you here? And the answer is 5/100. And again, on this one, there's 100 total squares that make up the ones cube. It got cut into 100 pieces, so each piece is 1/100th, and 5 of them are shaded red. So 5 out of the 100, 5/100. What decimal am I showing you here? And you could count the cubes, or you could realize that 2 full columns are shaded. And if each column is equal to a tenth, then 10 plus 10 plus 2 is 22. So 22/100 are being shaded. What fraction is equivalent to this decimal? Well, that number, the way you say it is 5/10, 0 and 5/10, and the way you write 5/10 as a fraction, they're equal. Both of those mean the same thing. They both are equal to 5/10. They're just written in different forms. One is a decimal form, the other one's written as a fraction. What fraction is equivalent to this decimal? And that would be 19/100. Another one. What fraction is equivalent to this decimal? Two and 38/100. What's the word form for this decimal? And it is 7/10. What's the word form for this decimal? 8/1000. Can you tell me the number form? I'm giving you the word form now, but now I need the number form. So if I say 0 and 46/100, how do you write that with numbers? There it is, 0 and 46/100. How about this one? The word form is 0 and 3/1000. How do you write that with numbers? 0 and 3/1000. Way to go. You made it through the video. Let's come back to the learning goal. So, goal of this video is that we would use our understanding of place value to model decimals, which I modeled a bunch for you. You practiced reading them and also writing them in different forms, and we only went up to the thousandths place. So hopefully you're feeling a little bit better about this. If not, come to class with questions, and we will continue to practice together. And just as a recap, we got whole numbers. We got our counting numbers. They start with the ones place and just go on for as high as you want to go. But we also have numbers that are smaller than 1, and those are decimal numbers. And those are and the whole numbers and the decimal numbers are separated between the ones place and the tenths place with a decimal point. And as you go to the left, places get bigger. If you go to the right, places get smaller. So thanks for participating, and I will see you on the next video.